Welcome back to another series of HVAC for Beginners. My name is Chris. I am your HVAC instructor for this evening. Today we're going to go over the fundamentals of the gas furnace components and get to the aspect where can the homeowner diagnose it compared to do you need to call a licensed HVAC technician to come out and service your gas furnace. Now that we're into the cooler temperatures here in the South, people are going to start using their furnaces more, and there are things on a furnace that can happen that are common events that can happen, but we're going to go over the components. I'm going to go over a book that I highly recommend that you get, that you can read and study off of. This book is used in a lot of schools. It is full of excellent information. It can be pricey, but if you shop around, you can get them used between $30 and $60 and $80. I promise you and guarantee you it'll do you loads of good, and it'll actually help you out in your endeavor to be that one homeowner, especially if you're mechanically inclined to do the repairs yourself and save you a lot of money. Nowadays, service calls are $60, $80, $90. After hour calls are over $100. Component prices are going up because of inflation and then get pretty pricey. So let's go ahead and take a look at the components that are in front of you. And we're going to go over a few, but there are some in here that if you're mechanically inclined and know how to use a multimeter that has an amp probe on it, you can go a lot further in this. I'm going to go over it from an aspect or a point of view that you don't know how to use a meter, but you can basically be able to self-diagnose just from visual acuities. We're going to start over on the right-hand side where it says fuse. You'll see a circle. You'll see there, and it has a fuse. That's the control board, and we will be going over that control board at up close so I can show you the wiring on your low voltage. The fuse is anywhere from a 3 to a 5 amp fuse. I recommend if you have a gas furnace, and it's basically a newer model, I don't care, 10 years or older and newer, they all have a fuse in it. It's an automotive fuse that's actually implemented into that control board for the low voltage side. So say you get a spike in low voltage, or for whatever reason there's a short in the low voltage and it'll pop the fuse and it'll save the control board from burning out. I recommend if you have a 3 amp fuse to put a 5 amp fuse, because it does vary in voltage and in current. Always remember that when you're dealing with voltage that has to do with a home, not a car, it's an alternating current. That means amperage and voltage and resistance can fluctuate minutely. It can go high, it can go low. If you get a ground, it'll go high. If you use a wire that's too thin, you call high resistance. So it's always alternating current. So I recommend you put a 5 amp fuse in it if you have one. So if you want to get a chance, you can go to your furnace, pull the door off on it. Your door is going to have an interlock door switch or a safety switch on it, so it'll automatically cut it off. If not, look for the power switch or the pull connection on your furnace and pull that before you do anything on the inside of your furnace. If you don't, you can put yourself in a jeopardy of being shocked by 120 volts. And believe you me, I don't care if it's 120 or 220, it hurts. And that's no joke. I've been hit before on accident, and it takes about 5-10 minutes to get your bearings back. So on the control board, you have the fuse. That's one of the components you can check. You can also check your low voltage wiring that goes to it, and we will go over that. Just above the fuse is a transformer. The transformer converts high voltage into low voltage. So it'll have you can get transformers that are universal that can do, say 208, 230, 220, 240 volt. They'll have a universal 120. And you'll wire it by the specifications if you have a gas furnace and or an electric air handler. it automatically will transfer 24 volts. Actually, it reads 27, like 0.1, 0.2, and that is your low voltage current. That's always called control voltage because it's always controlling something at a low voltage level. Your thermostat, of course, is not going to be connected to your furnace. They just put it on here as a platform. Your thermostat can be a 4-wire, which is battery operated. It can be a 5-wire, which actually could be powered by the transformer itself to the thermostat, going by the initial B that is on the thermostat. That would make it a 5-wire instead of a 4. A lot of times your thermostats are universal where you can run 4 or 5-wire. If you get up into one that has a heat pump, which you're not dealing with gas furnaces anymore, unless it's a dual fuel system, you are going to go, 7-wire, 8, maybe 9, 10-wire, just depends on what type of heat pump and who the manufacturer is and how many wires is exceeded to operate the heat pump system. You have an interlocking door switch. That's a safety switch. All of them have them nowadays. That's pretty much up the code. It kicks the power off to it, and try not to shock yourself type of issue. It'll run a feed across it, and it's basically just a kill switch on one side of the voltage that's coming in. You also have an inducer motor that'll kick in when you're actually heating up, and it'll transfer the gases up through the flute pipe and then out the chamber. Combustion chambers is basically where your burner tubes are, and in your burner tubes, instead of having rails, they'll have like 3 to 4 tubes in it and goes into a heat exchanger itself. You'll have a flame rod. Back in the day, old thermostats used to use a flame sensor and thermocouple, where you would have to go in there, turn the gas valve on, push down on the gas valve, light the burner, hold it for a few seconds, 30 seconds, then rotate it over to hold, and the burner would hold, and it would put a slight little flame across the thermocouple, which allows heat transferred into electricity into the gas valve to keep it open. And nowadays, we don't have those anymore. We have, some people call it flame sensors or a flame rod. And what will happen is it initiates an opening. It'll put a flame, the flame rod and flame sensor will get heated up by the flame. It'll send a signal to the gas furnace to keep it on, and it'll actually fire up. You'll hear the rails kick across, and you'll be ready to go. It does go through a sequence of events. You'll have your inducer motor kick in. You'll see your flame sensor, your inducer flame sensor or burner tube, whatever you want to call it. You'll see the igniter on it actually ignite, heat the gas, run across the flame rod or flame sensor. If it's working properly, it'll keep the gas valve open. If it's not working properly, within about a minute, it will shut off. And I want to go over that at this point, right here, right now. So we're going to go over a scenario with you. So say you go in there and your house is not heating properly. The first thing you want to do is go in there and turn the power off to the unit to reset it. Turn the power back on. Let the thermostat kick in. You're going to hear the inducer motor kick in. You're going to hear the flame burners tubes kick. You're going to hear them kick on. If it kicks off within, say, 30 seconds to 60 seconds, your flame rod or flame sensor has probably got a crack in the ceramic and is bad. That means it's not receiving a signal and it can't keep the gas valve open. That's a simple one to pick up on. But, learning how your gas furnace works, the best thing you could do is sit there and listen to what it does. If you're mechanically inclined and you have you're safe, you can actually pull the door off and hold in the door switch and watch everything work in sequence, and you'll get a better understanding of how that works. Don't be putting your hands near the burners. Don't put your hands near the flames. They will burn you. They also have thermal limits and flame rollouts. So a thermal limit is a limit of how hot that gas or the burners will get until it actually pops the little bimetal in it and will kick that thing off. Especially if you lose a blower motor and the burner still kick on, there's nothing to move that heat into the home, so it will overheat and kick into its thermal limits. It also has a flame rollout. Say that something happens to one of your burning tubes and the flame rollout is up there on your right hand corner by your combustion chamber. If it rolls on the outside and heats that up, it'll pop the bimetal and it'll keep it from catching on fire. It'll kick the gas valve off. All this is all safety switch oriented. To nowadays, there are safety and pressure switches in these things that are all in sequence of each other. If any one of those goes out, it will not operate. But there are simple things that you can check, and we're going to go over those simple things. I just wanted to go through a breakdown. Most of the time, if you're running into a situation where it's not even kicking on, it's not getting any power, you're getting flashes on your control board, that's a time to call in a licensed HVAC technician, because you got something more inherently wrong with it, and it's going to take a multimeter and some time to work with it to find out what's going on. This right here is the book I'm talking about. It's AHRI. It's Fundamentals of HVACR. That's heating, ventilation, air conditioning, and refrigeration. It's a comprehensive introduce the fundamentals of HVACR in a digestible unit supported by hundreds of colorful visual aids. It's written in a style that is easy to understand. The third edition of the Fundamental of HVACR introduces the principles of heating, ventilation, air conditioning, and refrigeration. The book is comprehensive enough to be used as a basis not only for HVAC courses, but for the entire HVAC programs. Units are short, they are digestible, they present themselves in complex materials and in a cohesive setup. They are straightforward mannered without every dumbling down its topics. Compared to other similar texts, Fundamentals of HVACR is visually stunning, features 2,900 supported photographs, illustrations, drawings, and diagrams, most of them in full color. The third edition has a revised to reflect expanded coverage of electrical, motor controls, motor applications, new technologies, regulations, and changes in the HVACR market, and remains most up to date out of your HVAC text material that's out there. Guys, brand new, it's about $160, but you can find these used all day long at used bookstores. You can find them online, go to eBay. I recommend you get you one of them. It will highly help you in your endeavor as a homeowner to be able to do fundamental repairs on your own that you can do and save yourself a lot of money. Let's go over components to troubleshoot in a residential gas furnace. Troubleshooting a residential gas furnace involves checking various components to identify and address issues. Here's a systematic approach to troubleshooting common problems with a gas furnace. One is your thermostat. If you have a straight heat and cool system, you're going to have a straight standard digital thermostat. The old Mercury thermostats may be still around if you can find one, but they have surpassed that. They're no longer fundamentally viable. With the upscale in digital thermostats, you can hang that thing upside down and it will fundamentally still work. You need to ensure that your thermostat is set to the desired temperature. Sometimes what will happen, and this is a common one, but I've done many service calls where they said they had a no heat call or no cool call. I go out, and when I go to the thermostat, the LED or the screen on it is not even lit up, which indicates it's not receiving power. The first thing I check is to see if it's battery operated. If I see 4 wires connected to it, I know that it's got 2 AA or 4 AA batteries, sometimes 3. And what has happened, those batteries have died, and the thermostat can't functionally work without, its supplemental power. Now, a lot of these thermostats nowadays are universal, where you can actually run another wire, which would end up being 5 wire, off of your control board, which basically powers the thermostat directly from the transformer. It'll receive power from its common and B side, and it'll actually fundamentally power it. How you check, basically, if you have a thermostat to see if you're receiving transformer power or 24-volt power to it, you'll go across your common and your R, and you'll get a 24-volt reading. That's how you know you're receiving 24 volts from your transformer and from your unit. You need to check your thermostat has power and is functioning properly. Replace batteries if the thermostat is battery operated, and then most of them are nowadays. People have battery operated, and I always tell them when I put in a new one, that it is battery operated, that it requires a AA set of batteries. I'll tell them how many. And I fundamentally suggest that they're replaced every year. Even though they can go up to 2 years, sometimes 3, you don't want to take a chance of that shutting down on you. Replacing them will keep you from having any kind of service calls or trying to figure out what has happened. Your gas supply. Verify that your gas supply to your furnace is turned on. Check for gas leaks around the furnace and gas lines. Here's a good recommendation. Most gas piping that comes into the home will have a flex tube on it. Under city code, you must have at least 3 to 4 inches of hard pipe going from the gas valve and externally sticking out at least 4 to 6 inches outside of the gas furnace for that flex pipe to connect to. If you ever get to one where it's leaking or you think that you have a leak, if it smells like natural gas, which is like a skunk smell, there should be a shut-off safety valve there on the line that you can physically rotate a ball valve and shut the gas off. And go get you a bottle, a little squirt bottle, and put some dish soap and water in it and shake it up and squirt across that. Okay. You can find a leak by using it. They also make gas leak stuff that you can get from an HVA store that you can purchase. Home Depot sells it. So does Lowe's. That's physically designed. You can squirt along there to see if you've got any kind of leaks. If you do, then that leak needs to be repaired because one, it's a gas leak, and it's, gas, natural gas is extremely flammable, and it will explode if it's initiated to any kind of internal flame source, and that's your gas furnace. If it lights up and there's enough there concealed in a confined space, it'll blow your house halfway wide open. So make sure that you are keeping an eye on those. What you can do regularly is just get you one of those and go along and squirt along those areas from time to time and see if you get any bubbles. If you see bubbles going, you can go get you an adjustable wrench, kind of tighten it a little bit. If you need 2 of them, get 2 and tighten it and try it again. You can save yourself a service call that way. But make sure that you're following all safety procedures. Just don't go in there and squirt water all over everything and then you short out your components. You don't want to do that. If the furnace has a pilot light, and guys, that would be an extremely old furnace, make sure it is lit. If not, follow manufacturer instructions to relight it. Check for faulty thermocouple if the pilot light won't start or light the ignition. You don't have to worry about those nowadays. Most homes do not have a pilot and thermocouple combination anymore. Your ignition system. For furnaces with an electronic ignition, that's what we mainly have now. Check for faulty ignition components. Listen for sounds of the igniter or spark during ignition sequence. So when it fires up, you're going to hear a ticking sound until the flame kicks in. That lets you know that it's sending a spark to ignite the gas that's going across the rails and or your burners. Make sure you follow that. Blower motors. A lot of times I've gone out and come to find out the blower motor bearings have gone out on it, and it thermally locked itself out because it had no way to vent out the heat it was producing, and it knocked it into a safe mode. Ensure your blower motor is running smoothly, lubricated if necessary. Check fan belts, tensions, and wear and on those systems. Most of your residential systems are direct drive motors. They don't have a belt on them. Only the older ones do. Commercial units will have belts built into the blower fan itself. So the motor and the blower wheel itself are separate, where on a residential system, they're all combined as one. The ventilation system. Inspect the ventilation system for obstructions or blockage. Verify the exhaust vent is clear of debris, snow, and on the pressure switch. Your pressure switch is there to indicate if that fluke pipe gets clogged up for any reason. It'll build pressure because it can't push it out, and it'll knock it out. Most common things you'll find in those fluke pipes are bird's nest or a dead rat. You'll find animals getting down in them. They'll climb in there. So the best thing to do, wherever that fluke pipe popped up on your attic, get a cover for it. One that keeps the weather and the snow out, and it has a screen around it to keep furry animals from getting up in there. Birds have been known to set them in there. Of course, it kicks in, it gets hot. The bird can't get out, or doesn't get out on time. It dies in there, but it's got a big nest in there, and it'll cause your pressure switch to set off. To test the pressure switch for proper operation, ensure that proper flow of combustion gas and checking the tube connections to the pressure switch for blockage. Your flame sensor, guys, that's one of the most common things that I have found when we're dealing with a gas furnace is your flame sensor. These have ceramic coatings on them, and they can crack after time, and then it doesn't work properly. Clean the flame sensor if the furnace starts to build what they call, the flame goes out quickly. Now, that's another thing. On the end of that flame sensor, has like a little L shape or a straight bar. You can clean those if it looks like it's got carbon buildup on it, and then try it again. If it's not working after that, you have to replace it. Ensure the flame sensor is properly positioned in the burner, and it has a specific way it goes. It will only go one way, ladies and gentlemen. Limit switches. Check the limit switch for continuity. So if you take a limit switch and you go across it, you should be able, if you set it on continuity, it makes a beeping sound. When you go across it, it should be naturally closed. You should get a beeping sound. If you go across it and you get no sound, that means it's open and it's faulty. The limit switch can cause the furnace to overheat and have issues. So the limit switch is there. If it tries to get too hot, has a biometal piece in there that bends and it continues the continuity across it. If it goes bad, it'll actually keep your system from coming on. Check your limit switch for continuity, as it said. Make sure that your furnace doesn't overheat. Control boards. This is another one. This is where that little bitty fuse is, that 3 to 5 amp fuse that can actually give you such a headache if you don't pay attention. So most of the time, that little fuse is popped. For whatever reason, it got a surge and it popped. Replace, turn the power off, put the fuse in, and turn it back on. You'll be operating right back to where you need to be if that's the probability. If you pull it and you look in the center and it's burnt, it's bad. Inspect the control board for burnt marks or damaged components. Check for error codes on the control board if available. On the side panel of your door, no matter what unit it is, it's gonna, if it has where it does control areas, it'll have a list of those control areas, because that control board will give a sequence of events. Let's say like it's number 2. It'll flash twice, it'll pause, it'll flash twice again, letting you know that it's number 2. It might be number 7, number 8, number 13. It might flash once, pause, and then flash 3 times for 13. Make sure you test your gas valve to ensure it's open and closes properly. Check for a faulty gas valve. If there's no gas flow to the burners, it's not going to kick on. These gas valves from time to time will go bad. It's not too often that it does, but it will go bad. These are the common things that you can check on them. A lot of them require a multimeter. If you are handy and you are mechanically inclined, you can learn these. The book will help you along the way as well. Gas furnace control board. This is what I wanted to talk about. You'll have a connection here. That little white connection has a connection that'll feed in off the control board, and it'll actually go into your HSCI, your 1. All the rest of these, these are capacitors. The ones on the bottom are blue. The little ones, they're all capacitors. These are dip switches. And what you need to do, if you ever have to replace one of these control boards, make sure you're setting your dip switch to the same way it's set on the control board that you're taking off. There's a certain way these dip switches work, and if you don't set them properly, you could not get your system to operate properly. The railing that you see with the Phillips head and flat tip connected combination screws is where your control wire goes in. The Y, the G, the W, the R, the C have a fundamental reason for working. Now, on your home itself, you're going to be hooking up your 4-wire system. You're going to have power, heat, D for fan, and then sometimes you'll have B for common. But you're going to get a 4-wire. This is a 5-wire. Yeah, cool. Y is for cool and common. So when your condenser outside is, if it's a 2-wire condenser, it'll be 2 wires coming in from condenser. One goes to common, one goes to cool. These two here, common and cool, Y and C, operate your condensing unit outside. Everything else operates the indoor. You have R for power, white for heat, and G for fan. They're also color coded on your wires. You're going to have a yellow wire. You'll know that that goes to cool. You'll have a green wire. You know that's fan. You'll have a white wire that's for heat. you're going to have a red wire for power, and common sometimes will be blue, and it's connected here. You'll have wires that run off that way. Sometimes you'll have a B. But that's the fundamental settings of your gas control board, and this is where the wires from your thermostat connect to your control board. And then from there, you're going to feed the wires in from your condensing unit in here. So this whole system right here is where your condenser is connected to, low voltage wise, and your thermostat. This is the fundamental control that tells the system what to do. The thermostat kicks in. If you're calling for heat, it'll tell it to call for heat. If you're calling for cool, it'll tell it to call for cool. So now we have your specific wiring diagram. I know there's a lot there, but I want you to not be discouraged. It looks like a lot, but it's not. Okay? I want you to look over here on your thermostat right here. It's a 4-wire. It's going to run heat, W, power, fan, and cool. This is going to be coming from your thermostat terminals. It's a 4-wire and it's battery operated. You're just going to make the connections same way from your thermostat to the control board, which is right here. It says 2-wire heating only. Your W will go to W on your control board. Your power is going to go to power on your control board. Your G for fan is going to go to fan on the control board. And your Y is going to go to Y on the control board. On the common and Y, they're going to come from your condensing unit. You'll see little area that says condensing unit. You're going to have F and Y out there. It'll still say common. It's only going to be 2-wire. It'll be red and white. Might be red and blue. Might be, you know, blue and green. It's just whatever they're using. At one side will go to common. The other side will go to cool. And that completes the circuit. Your condensing unit, I want you to disregard over the right side where it says single phase. All residential systems are single phase compressors. And you're going to have your power feed in that. And we will go over high voltage at another time. Note, if any of the original wires are supplied, they must be replaced. Use sample type or evaluate your wire. Field wire, low voltage wiring. Field high voltage wiring. Factory high voltage wiring. Heating and cooling application wiring diagram. This is courtesy of Carrier. This is kind of what Carrier does. See where it says low voltage terminal block? Okay. Kind of an older style. They'll have a terminal block. Basically, that terminal block is your control board. And this is where it's at. Your high voltage will feed into it. It will come through. It'll drop down and feed into it because your blower will connect to that as well. And you'll see it on your control board. If you ever take the time, you can actually look at your own system and figure it out. Really, really easy. Well, guys, that's a simple setup for your gas furnace and your components. I know there's a lot there. Leave a comment down below. Tell me if this was a little too much for you, if I need to simplify it. If I do, then what we need to do is I'll go ahead and do a simple video starting with the thermostat, and then I can start with the control setting, and then we can start with the condenser. Since it is now in the wintertime, I'm going to fundamentally focus on gas furnace or electric and show you how it works. Guys, I appreciate you being with me here at HVAC for Beginners. We will see you on the next episode. And with that, I hope this has helped you out. This is Chris with HVAC for Beginners. Till next video.